Howdy. Just a quick read through. It's late already. EOS. Tides ripple across Earth's plasma donut. The interactions between lunar gravity and the terrestrial magnetic field may cause a 90-degree offset from the Moon's position in its orbit. Earth is surrounded by an ocean of plasma, an electrically charged fourth state of matter. And researchers have discovered tides rippling across its surface. The shifting field of plasma surrounding the planet may affect Earth's radiation belts, which can damage spacecraft or astronauts in orbit or traveling to or from the Moon. Similar tides could race around planets in other systems, that research suggested. Yeah, that's how the universe works. The plasmasphere is a donut of cold plasma centered over Earth's magnetic equator within the magnetosphere, the region encompassing our planet's magnetic field. The plasma is supplied by the ionosphere, the electrically charged layer of the upper atmosphere. No, it's supplied by the Barkland current. The outer boundary of the plasmasphere, known as the plasma pause, is typically found about 20,000 to 38,000 kilometers from Earth's center at the magnetic equator. Although its location can vary with seasons, solar activity, and other factors. Quang Qixi and Xiao Xiao, physicists at China's Shandong University and the study's lead authors, wrote in an email. Plasma tides. In the past, lunar tides were mainly found to affect the first three states of matter: solid earth tides, liquid ocean, and neutral gas dominated atmospheric tides, Shi Xiao wrote. Whether lunar tides can influence the plasma dominated regions had not yet been explored. It is explored. To fill in that gap, Xi Yaxiao and their colleagues combed through a database of more than 50,000 plasma pulse crossings recorded from 1977 through 2015 by NASA's twin Van Allen probes that 5 spacecraft Themis, time history of events and macroscale interactions during substorms, missions, Europe's 4 spacecraft cluster mission, and others. Because solar flares and the related phenomena can cause substantial changes in the plasmasphere, the researchers eliminated readings taken when the sun was active, leaving almost 36,000 observations. But why? The researchers eliminated readings taken when the sun was active. What, 14,000 readings just dropped off this? Amazing. Let's go on. Their analysis revealed tides in the plasma pulse that ranged from 0.12 times Earth's radii, 300 kilometers above average at high tide, to 0.14 times Earth radius, 350 kilometers below average at low tide, a difference of just 3% in the smoothness of the plasma pause. What? Ocean and land tides are highest and lowest close to new and full moon. Now it's full moon. When the moon aligns with Earth and the sun, and lunar solar gravity pull along the same line. Unlike those tides, however, the plasma tides are offset from the moon positions in the sky by 90 degrees. High plasma pause tide occurs when the moon is at first quarter, and low tide occurs 2 weeks later at last quarter. The tidal waves in the plasmasphere occur once per day and once per month, versus twice per day and twice per month cycles for ocean and other tides. It is reasonable that the moon has a small but noticeable effect on the plasmasphere. Yeah, maybe it has a much bigger one, says Jerry Goldstein, the space physicist at Southwest Research Institute in San Antonio who studies the plasmasphere but was not involved in this project. The most surprising thing is that the largest effect is 90 degrees away from the lunar direction. Intuitively, one might expect the largest effect to line up with the moon. The plasma pulse tide itself is caused by the moon's gravitational pull. No. According to the researchers, but the 90 degrees offset is more difficult to explain. Yes, so maybe the first thing, the gravitational pull, is wrong as well. 90 degrees wrong. It doesn't vary with the lunar phase. The Earth-Moon distance changes in seasons or any other known factors. That means it's not caused by gravity alone, but by gravity and electromagnetic force working together, the researchers said. Yes, because gravity is tied to electromagnetic force. It's about the charge of a planet or planetary body or whatever. It's the charge which makes gravity. Gravity is just a byproduct. If gravity would be 1, then the electromagnetic force would be 10 to the 39th potential, which would be a 1 with 39 zeros. One possibility is that electrically neutral winds in the ionosphere, which vary with the moon's phase, modify electric currents that thread along magnetic field lines through the ionosphere and into the plasmasphere. The currents might disturb the magnetic field, pulling the plasmasphere out of sync with the motions of the moon. The researchers noted that this mechanism is poorly understood, however, and is a subject of ongoing research. Ka-ching, more money. The plasma tides may indicate a fundamental interaction mechanism in the Earth-Moon system that has not been previously considered. Xi and Xiao wrote in their email, this is to say lunar tides may not be ignored in the study of the magnetosphere. Diving into plasma physics. The tides in the plasmasphere could have implications for space travel and studies of other planets in our solar system and beyond. Magnetospheres have been detected on other planets, the study authors noted, suggesting that plasma tides may be observed universally throughout the cosmos. Yes. Opening new avenues for research into planetary systems and other bodies with strong magnetic fields. Earth's magnetic field plays an important role in space flight as well. It deflects cosmic rays and particles of the solar wind, offering some protection to craft within the magnetosphere. Yeah. It protects us. However, it funnels other particles towards Earth's surface or traps them in the radiation belts, potentially threatening spacecraft and astronauts, particularly when they travel to the moon outside the protection of the magnetic field. We suspect that the observed plasma tide may subtly affect the distribution of energetic radiation belt particles. Were they relativistic electrons at the radiation belts, which are well-known hazard to space-based infrastructure and human activities in space, the authors noted. Yeah, human activity in space. They probably talk about us in general because Earth is in space and we are all on Earth. Human activities in space. Welcome to Earth. It is therefore worthwhile to look for evidence of this effect in future studies. Understanding this new result is going to require a fun dive into some basic space plasma physics. Yes, start with basics. This would be a good thing for you. Start all over again. Whole cosmology has to start all over again. Understanding this new result is going to require a fun dive into some basic space plasma physics, Goldstein said. Let me show you quickly if I find it a video from a dude who has the same name as I do, but he knows much better, and he has a very good way to explain it. I think I found something. Let's have a look at that quickly, and I will put a link below. You can check his channel, give him thumbs up. He does really nice work, and he has a nice pace.
The Earth possesses a strong magnetosphere which redirects a lot of energy from the Sun and cosmos around and away from the planet's surface. And the pressure from these charged particles causes the Earth's magnetosphere to stretch away from the Earth in the downstream direction, forming what's known as a magnetotail. Because of the close proximity of the Moon to the Earth, every lunar rotation has the Moon passing through the Earth's magnetotail. And this occurs, as you guessed it, during the full moon, as the Sun, Earth, and Moon are in a linear arrangement at this time. About 3 days before the Moon reaches its max luminosity, it enters into Earth's magnetotail, and it takes about 6 days to cross and exit to the other side. While crossing the Earth's magnetotail, the Moon passes through huge volumes of highly charged particles known as plasma, the fourth state of matter. The plasma contained in the Earth's magnetotail is a very dynamic structure that's constantly in motion. And as the Moon orbits through the magnetotail, this plasma sheet can sweep across the Moon many times, with encounters lasting from just minutes to days. The lightest and most mobile plasma ions are electrons, and as the plasma of the magnetotail sweeps over the Moon, electrons stream towards the barren surface, causing a negative charge to accumulate. On the sunlit surface of the Moon, solar ultraviolet radiation keeps the accumulated negative surface charge from the electrons relatively low. But on the dark side, the lunar surface charge accumulates unimpeded, being able to spike into the kilovolt range. In a magnetospheric feedback mechanism, when the plasmas of the magnetotail sweep away from the Moon, the ions accumulated by the lunar surface are pulled back into the Earth's magnetosphere and then travel to Earth due to the downward electric field of the magnetotail. Just as with the Moon, as these ions reach Earth's surface at night, they increase the Earth's surface electrical field and also increase its variability. During a solar storm, when more energy is flowing into the Earth's magnetosphere than normal, the electromagnetic effects of the full moon in the magnetotail are even greater.
Yeah, I think somewhere here the commercial hit. So let's continue with that.
Okay, so now we can look at some of these plasma flows for the Earth. This is all basically plasma that we're seeing here, and this is the Earth right there. This is the magnetopause, which is the outer boundary of the magnetosphere. The sun is off to the left. Here we see plasma ions, and they're given a directional arrow, and the red arrows are faster velocity plasma ions. And you can see a lot of them are actually streaming back towards the Earth. Because when there's a magnetic connection, when a magnetic field line connects with another field line, due to changing magnetic field conditions, the energy stored in those field lines is then transferred into the ions surrounding that connection event, and streams of high velocity plasma shoot out from either side. So when you get a magnetic reconnection, you get plasma ions shooting towards the Earth and also plasma ions shooting away from the Earth. The reason these reconnection events happen is because solar wind and coronal mass ejections contain their own magnetic fields. The sun basically is blasting off magnetic fields. Here you can see the solar wind right there. This is a generalized one. But these solar wind plasmoids, as they're called, when they interact with the Earth's magnetic field, it has to adapt. And this can cause reconnection events, and then it can cause streams of particles that go earthwards. So there can be significant energy interactions that happen during strong solar events like we've been seeing because of solar cycle 25. That is one of the forces that is loading the Earth with energy right now, directing energy earthwards. And then we also have, of course, the moon now about to move through the magnetotail, which is going to take some of these plasma ions that pass over the moon and direct it earthward as well. So there are multiple factors. Here, we're looking at this so we can watch the plasmoids that the Earth sends off. And you
Yes, watch the whole video. Here he has a much better language skills than I do, but I just wanted to share that with you. Since we have full moon and some scientists are going back to the drawing board and study basic plasma physics. Maybe they should just check his videos and they could learn so much. But I don't know, what do I know? I just wanted to share this with you. Thanks. Bye.